Speaking about our guest, so as I said, today we are very happy to be joined by Herman, and I will let him tell a few things about himself shortly. One more thing from my side, and then I will pass over to Herman, is that you need to be aware that everything you see in this call has an educational scope. So if you like to use our services further, you may connect with somebody from the Oracle account team. Also, if you watch any of our sessions recordings in the future, keep in mind that there might be some slightly differences in the Cloud Console menu since we enhance our products on a regular basis. That was all on my side. Herman, over to you.
Okay, thank you, Violeta.
You're welcome.
I'm going to share my screen. Okay. Can you see a presentation?
Yes, all good.
Great. Okay, so first of all, thank you to the organizers, Violeta, Tom, Ettore. Thank you for organizing this and giving me this slot. Today, I'm going to talk about Rust, and I want to basically take you through my journey of connecting autonomous database to Rust. I'm not a Rust expert, I'm Herman Viscuso. I'm a database expert, especially when it comes to the autonomous database, but I do have a developer background. I have been developing in Java and JavaScript for a long time, but I'm new to Rust, right? So I said, okay, let's learn Rust and let's connect it to autonomous database and let's see how it works, etc., etc. So I want to share that journey with you today. And my main objective is to get you up and running. Just basically, you configure everything to start playing with a couple of bindings that are available for us, and you are up and running to basically test how it works, basically test the performance later, etc., etc. We won't have time to go deep into, like, let's say, advanced usage of those bindings, because we'll have to set them up and configure it, configure the whole thing. But we will take a look at the basics, how to basically do queries, how to maybe create a table, how to maybe insert some rows there in the tables, etc. But we have to do to go through a lot of background, okay? Because we have to do a lot to get everything correctly set up. So if you are on a Mac right now, if you are on an M1 or M2 based Mac, then you are in luck, because that's my current setup, and I had to go through some hoops to basically get everything up and running. And so I will give you a lot of information regarding to that. So unfortunately, I cannot cover like multiple platforms like Windows, etc., etc. So this is basically what I got and what I had to go through. I think that for developers, it's very common to have maybe M1 and M2 Macs. Okay, so okay, let's get started. First of all, the prerequisites. Okay, what do I need to follow this webinar and basically to run the demos later? So what you need is Rust, obviously, right? So I'm running version 173.0, and I'm running those crates that you see there. Basically, I have dependencies. One of them is called Oracle, which is the Oracle Rust binding. I'm going to talk about that. We are going to take a look at another binding called Civil. So two for the price of one. We'll be checking out two different type of bindings, but I'm also using Tokyo and Actix Web for let's say non-blocking capabilities, which we are also going to see today. Okay, so basically when you use these bindings, you can opt for a blocking way of doing it, where basically the code waits for the database code to return, or you can opt for async, right, non-blocking, and you can go do something else while you're waiting for the database code to come back. Okay, so I use Cargo, obviously. If you're familiar with Rust, Cargo is like the package manager. Okay, and I install Cargo Edit there because I like to add dependencies doing Cargo Add. So for example, if you install this Cargo Edit extension and you want to add the Oracle dependency, you go to the root folder of your project and you just say Cargo Add Oracle, and that's really cool because you can create a project doing Cargo New and the name of the project. That creates a folder for you. You CD into that folder, and then you do Cargo Add Oracle, and that's being added for you in the cargo.toml file, which is where the dependencies are. Okay, then you will need Oracle Instant Client. Why do we need Oracle Instant Client? Because these bindings are using loading dynamic libraries that are part of the Oracle Instant Client to actually connect to the database. So the Oracle Instant Client has several libraries inside, both simpler like ODI PC and OCI. I'm going to cover the differences between those libraries, but basically this is a requirement because we need the libraries to connect to the autonomous database. Now, if you go and look for the Mac versions of this Oracle client, you will see that they are only available for Intel-based Macs, and that is a problem because I'm running on an M1 Mac, right? That's ARM. So you will have to use Rosetta 2, which is like a translation layer that basically allows you to run Intel, compile Intel code in an M1 or M2 based Mac, and that's what I'm using here. And I will basically cover that, okay? Finally, we need the Oracle Cloud infrastructure because we are going to run the autonomous database in the cloud, okay? And the good news is that it's enough to have the always free tier. So even if we don't have credits, like maybe we're on the free trial, we run out of credits, you get $300, something like that. So even if you revert it back to always free, you can run this code. Okay, no problem. We can use the always free autonomous database. Now, optional, I like to install the OCI CLI. The OCI CLI is pretty cool because it allows me to basically set up an OCI configuration that later the Visual Studio plugin extension, the Oracle developer tools will basically use right away. So if you configure the OCI CLI, these two lines, the first line is basically the bash line is installing the OCI CLI, and the second line is configuring it. When you configure it, you get a guide. You get like a wizard that will basically walk you through how to configure the OCI CLI, will connect you to your OCI tenancy. And once that's ready, you will see that in your home directory, you will find a .oci folder with all the configuration files. That's what the Visual Studio extension for the Oracle developer tools is going to read, okay? And it's going to do that automatically. So you don't have to configure the Visual Studio Code extension. Basically, it will take this OCI CLI configuration. So highly recommended, even though it's optional. And then obviously Visual Studio Code, you might choose to develop for Rust in a different environment. This is the environment I'm using. I feel very comfortable with it. I'm using Visual Studio Code, the latest version. I'm using all of these extensions. And we will take a closer look at the Oracle Developer Tools extension, okay? But I'm also using Rust Analyzer, Crates, even better TOML, Code Runner, Code DB, etc. So these ones basically give me intelligence for Rust, give me pretty, basically colors, auto completion, etc. All right, so let's take a look at why at the languages, right? Number of developers per language. So this is a combination which is basically the main source is the Stack Overflow annual service. You probably completed that one. You went through that one if you're a developer, okay? So this is sent to basically all developers in the world, and they complete it. So if you take a look at the 2022 instance, which is old, right? This is 1 year old. You'll see that Rust made it like maybe number 10 with 1.1 million developers, okay? But things look very different in 2023. So why we are focusing on Rust on this session? For example, right now, the number of developers is about 3 million for Rust. So if you compare to 1 point something in 2022, you could say that in the last few years, the Rust community or the Rust developers are doubling, right? So it's growing like crazy. So it's growing a lot. And one of the things that we saw in that Stack Overflow survey is that it's been the most desired language for the last 8 years. So 8 years in a row where people say, hey, I want to learn Rust. Rust is something that I want to take a closer look at, right? So unfortunately, sometimes it's I want to, but people don't have time, right? But I think that there are multiple reasons why you should take that I wanted to for real, try out Rust and play with Rust. And this is an excellent excuse that we have today because we're going to connect to autonomous database. So why Rust? Because it's safe. It doesn't have garbage collection, and it has an ownership system where if some maybe function is using a specific element, now nobody else can use it, right? So you can avoid a whole set of problems with that. because you things are being accessed as the way they should and from the places they should be accessed from. Okay, so it is fast because it's compiled, it's not interpreted. If you consider JavaScript, Python, etc., they are interpreted languages. This is compiled. Every time you do something, you will see that every time you bring those dependencies that I mentioned, those things are being compiled natively in your own machine. So it's like having like a C++ compiler running in the background, giving you a binary that it's mostly comparable in terms of performance to C++, to give you an idea. So it's really, really fast. Now concurrency, it has multiple options for concurrency. It has, you know, async awaits, like if you did JavaScript development, you're very familiar with it. So it has multiple libraries that you can use. Well, the most popular I think is called Tokyo, and also has a very robust, package manager called Cargo. I really like Cargo. It's very robust. It's kind of transparent because nobody talks about Cargo, but that means that it works. You know, it works. It's very robust, and you don't have to, you know, basically worry about, you know, those dependencies and those bringing those dependencies, those projects, maintaining those projects, etc. Then we have Clippy. I'm not sure if you are a Rust developer. A lot of you basically answered that you are more familiar with SQL. I saw a lot of SQL, and that's not surprising because SQL is in the top 10 language every year. Okay, so everybody's doing SQL at some point of or other point in their lives. So Clippy is basically a very pedantic agent that will tell you everything that is wrong about your code. So every time you're trying to build a specific Rust project, Clippy will show up there saying you, hey, you did this, but you probably meant that, right? Or hey, this is not how you're supposed to do this. Maybe this piece of code will help you, you know, that kind of thing. So I like it because it's not a compiler error. Clippy is like an agent, and it's working on your behalf to have you make or create the best Rust code possible. So some people hate it because it's very pedantic and it's complaining all the time. But I really like it because I learn a lot from Clippy, because Clippy gives you code variants that you can use, etc. And you get that in the same screen where you see the errors. So Clippy is integrated in that system that is building your Rust code. So it has type inference. It's really nice. You don't have to explicitly call out the types, unless it's absolutely necessary. In some occasions it is necessary, but still the language has strong static types, which means that you cannot fool around with how things are working. You need to define specific types, and if you want things to behave differently, you also have traits to basically define how things behave. And then you probably heard about zero-cost abstraction. Zero-cost abstraction means that you can have generics, you can have traits, you can have all sort of things that are available in modern languages, and that doesn't have a penalty on the generated code or the compiled code. So the code is not slower because it's supporting generic traits, etc., etc. So that's basically all right. Enough of Rust. So we want to connect to the Autonomous database. Autonomous database is an Oracle database, and there are multiple ways in which we can connect to Autonomous database. So you have drivers that basically connect natively, meaning that they are not using any library. And maybe if they are using those libraries, they are using them in source code version, like for example JDBC, that you can see in the very left here in the screen. So, but those are basically the most robust and the most, say, official connections, like ODBC, JDBC, etc., etc. But then the rest of the, let's say, drivers in this world or bindings, I'm going to use the word driver or binding interchangeable here. Okay, so I'm talking about the same thing. Talking about this basically bridges that allows us to connect to the database. There are two types. Ones that connect directly to the Oracle Call Interface, or OCI. So this is not the Oracle Cloud Infrastructure. So this is a different kind of OCI, Oracle Call Interface. And then we have others that connect to the Oracle Database Programming Interface for C, ODPI-C. Okay, and we're going to take a quick look at the differences between these two libraries. But basically, we're going to take a look at two of these Rust bindings, and you can see them here, We have this one here that is using directly the Oracle, the Oracle Call Interface, and that one is called Civil. This is one of the bindings I'm going to take a look at. And then we have the Rust Oracle, or just Oracle in the dependency, which is here, which connects to the Oracle Database Programming Interface for C. Okay, so you might be wondering, what's the difference? Suppose I want to create one of these bindings for a new language that comes up, right? What is the difference? Where I should take a closer look at? So basically, if you take a look here, you will see that the Oracle call interface is a low-level API. So it's more complex, provides more control over all aspects, and it's flexible because it's very low level. So it allows you to basically, integrate them into higher level APIs. So these are basically the building blocks if you want to use them, and it's native. It's provided by Oracle itself. It's a native method to connect. It includes all the Oracle specific features and optimizations, etc., etc. So it's the big brother. Okay, it's more difficult. Then you have the Oracle Database Programming Interface for C, which is basically a wrapper on top of the Oracle call interface. So it's a way to make the Oracle call interface easier. It's a high-level API. It's open source. It abstracts away a lot of the complexities of OCI. It's easier to use for the developer. So if you are using this ODPI./C, it's going to be easier for you to create one of these bindings. But you have to keep in mind that this is an open source project that has its own development cycles. So there it might not be like completely in sync with the latest OCI version, right? Maybe the latest OCI version goes out, and then this one, the Oracle Database Programming Interface for C, gets updated maybe a bit later. Okay, and you might want to take a look at the functionality to see what you need in that specific binding. All right, so let's move on because we have a lot to cover. So you'll have to install the Oracle Instant Client. So it's a set of libraries, as I mentioned before. All of these bindings that I just mentioned that rely on these two types of connections, the OCI and the ODPI-C, they will need the libraries, okay? And you will see that we need the libraries for both of the bindings that we covered today. You have to go ahead and download them, okay? So I downloaded the one for Mac OS that you can see in the top right, but it came available for Intel, and I have an M1 Mac, right? So we are going to go through that in a bit. But first, the bindings that we covered today are Rust bindings. We are going to cover this one called Rust Oracle, or just plain Oracle. This one is open source. It hasn't been created by Oracle, but it has been created by Kubo Takehiro from Japan. It's an open source Oracle database driver for Rust, which is based on ODPI-C, right? Okay, so we saw OCI and ODPI-C. It's based on ODPI-C, and it's the most downloaded Oracle DB binding by Rust developers. About 2.5K downloads per month, okay? And it requires the Oracle client installation because the ODPI-C libraries are there and the binding will use it. And they will obviously have to be exposed, basically added to the path of libraries in your system so they are visible. So a very common error that you get is like, I cannot find a specific library. When you try to run this, that means that your library is not exposed, it's not visible, okay? And we'll go through that. The second binding is called Civil, okay, or Civil, depending on how you want to pronounce it. So this is another open source driver by Alex Demenchuk. So this one also has not been created by Oracle. It has less downloads. I think that kind of 20 times less downloads than the other binding, and also seems to have not so many contributors, okay? But it's still great in terms of functionality, as we will see, and it has a great feature that comes out of the box that the other binding doesn't have, which is support for non-blocking async APIs. So you don't have to wrap and create your own, async calls. Basically, this comes with the library. And I think that's really, really cool. Okay, so this one uses OCI as the underlying library. So basically, it took more work to create this one because OCI is a little bit more complex. Okay. All right. So first of all, we need to install Rust. All right. I think I can actually skip this, but just in case, and we're going to share the deck later, I wanted to give you all the steps that you need to get up and running. So here, this is how I installed Rust. And this gave me restap, rustc, which is basically the compiler, and cargo, which is the package manager. So if we have to, target specific Intel platform, like we will see once we install Rosetta 2, we'll have to basically run our code specifically for Intel. Otherwise, it will be detected automatically. So we can add we should add the target that, as you can see here. So you will see that every time I do a build or a run, I will be targeting x86. Okay, and this is because I will be running Rosetta and I need to compile for 86. So keep this in mind, but you will see it live. Okay. Now, if you are on an M1, M2 Mac, you will have to install Rosetta. How do you install Rosetta? And as I mentioned before, Rosetta is basically a translation layer that allows you to run Intel binaries right in your ARM-based Mac. That is interesting. And you will say, hey, but this is not, this won't be fast, right? Because I'm doing this weird, CPU translation in the background, etc., etc. So to give you an idea, if you have a modern M1-based Mac right now and you're running Rosetta, you will get a performance similar to an Intel-based i7 from 2020. So if you had a Mac in 2020 with an Intel-based i7, you will get that kind of performance, to give you an idea. So it's not so bad. It's not the best, but it's not so bad. So this is how I install Rosetta. And I also, just let me go back, added a few things to my, my profile, because every time I run my command prompt, I wanted to have these aliases. I want to type Intel and basically have Rosetta switch to Intel. And we will see how I do that when I type Intel. And then I want to type ARM and I just basically have Rosetta switch back to ARM. I'm not using ARM a lot because when I do Intel and I go into the Intel mode, then I type exit and I go out of the Intel mode and come back to the ARM mode. So I'm not using ARM, basically using Intel, okay? Now I created this export on PS1 because I want the prompt to turn yellow when I'm running on Intel, okay? So every time running on Intel, I want to see yellow because I don't want to mix things. I want to completely understand that I'm basically in Intel form, okay? And we'll see that. All right. So installing the Oracle Instance Client for Mac. So I downloaded that zip file that I showed you before. You can Google for Oracle Instant Client and you will see, a whole bunch of options. If you are on Linux, for example, you just Oracle Linux, you can use DNF to install it. So you don't even need to download the zip file. But the latest one for Mac is this version 19.8. So I downloaded the zip. I uncompressed it in my basically home folder, okay? And I got this directory called Instant Client 19.8. Then I created in my home folder a lib directory or a lib folder, and I created this symbolic link because this the bindings that I've been trying with Rust were complaining about this library being missing. When I was trying to run Rust code, so I linked this specific library to this lib. And then I obviously exported the lib to be in the library path. So take a look at the exports. What we're doing here is saying the Oracle home is this instant client. I'm going to add the libraries in this instance client to the library path, and I'm going to set up a whole bunch of other dynamic libraries, paths. Okay, so you can basically go ahead and copy that if you have a Mac, or maybe if you have a Linux, it will be very similar. All right, so now we're going to create an autonomous database. And for that, I'm going to use Visual Studio Code in a while. But basically what we're going to do is we're going to create the instance via Visual Studio Code extension, because extension also has lifecycle management, not only basically running SQL or connecting to the database, but also allows you to create a database, which is really cool. Then we're going to do lab 2. I don't think we're going to do it lab 2 because I already did it, but it's basically taking information from object storage and just dropping data, creating a few tables with movie data, so we have something to work with. It's very easy, very straightforward. It's just dropping a file into data load and basically putting data in a few tables. You can use your own data, obviously, if you have data inside the database. We are going to download the wallet because when we are working with the always free version of autonomous database. We use wallet-based authentication. So we download the wallet, we put it locally, and we use it to authenticate to the database. And for that, we need this export. We need to export TNS-admin to point to the wallet. Okay. And also, once we downloaded the wallet, if we go inside the wallet, you will find a file called sqlnet.aura, and we have to update the sqlnet.aura to basically point to the wallet. Kind of strange because we need to change the wallet itself to point to the wallet, but don't ask me. That's where we need to basically get things up and running. Okay, if you take a look at the bottom part of this, box, you will see that there's also a very easy way to create an autonomous database from OCI. If you just go, if you install the OCI CLI, okay? All right, but what's autonomous database? Some of you might not be familiar with autonomous database. So we took the Converge Oracle database, which is good for any workload, any type of data, and we took it to the cloud. Basically, we place it in OCI in a self-service manner. You will see that it's very easy to actually, create an Oracle database. It's just maybe 2 minutes, and we are done with provisioning an Oracle database, right? So that database is running on top of Exadata infrastructure, okay? So it is the fastest possible hardware ever made for an Oracle database. So you're in the best hands when it comes to what's really running that Oracle database. The best one, and it's only available within OCI, okay? But that's not all. We also added machine learning on top because we wanted this database to be self-tuning, self-securing, self-patching, etc., etc. So that's autonomous database. The best of Oracle database, the best of cloud, and the best of machine learning to give you the database technology for the 21st century. So you might be asking, okay, what is Oracle database running by itself? What is it doing by itself? We're talking about automatic tuning, automatic scaling, automatic provisioning, automatic encryption, automatic updating, automatic configuration. Actually, there are more, obviously, but we are doing everything for you behind the curtain. So you as a developer can focus on building the application that connects to the database and not basically maintaining the database lifecycle, okay? All right, so as I said before, we're going to provision the database using Visual Studio Code. So let's go straight into that. See how we're doing with time. Okay, I think we're fine. Okay, so what I'm going to do is, if you take a look at this, you will see the Oracle Developer Tools. Okay. So this is the plugin that you have to install. So if you just install the Oracle Developer Tools for VS Code and you already run the OCI CLI setup, OCI setup config, then this will automatically connect to your tenancy, right? And you will get this extra icon here, which has the shape of a cylinder, like a database, okay? So basically, let's refresh here. Refresh. So basically, you will see this. You will see default, and you will see your tenancy name here, okay? And you will see this automatically. Now, if you just click on this arrow here, you will see that you have the autonomous transaction processing, autonomous data warehouse, and autonomous JSON databases. So we have variants. When you create an autonomous database, you can choose to create an autonomous transaction processing instance or an autonomous data warehousing instance or a JSON instance. So the typical application that is going to do like, OLAP, transaction processing all the time, you have to choose autonomous transaction processing because that engine is optimized for that. A lot of inserts, a lot of queries, etc., etc. Typically, I don't know, maybe like a shopping cart kind of application, stuff like that, maybe banking, etc., etc. But then we also have a specially tuned version for data warehouses, which is the ADW. So if you're going to deal with, a lot of analytics, a lot of, columnar, maybe kind of operations, etc., you can go ahead and choose autonomous data warehouses. Okay. So what we're going to do here is going to create an ATP, and let's do create new. And if you are in the always free tier, remember that you can have only 2 of them. This one has been terminated, so I think it's not going to give me any problem. And this one I have because I have all the data for the demos. I think that we can create one now because this one in red has been terminated. We have 1 and we can have 2. But this is if you are in the always free tier. If you have credits, you can have more, and if you're paying for it, you can have as many as you want. Okay, so we're going to create a serverless version of the autonomous database. You have two variants: serverless and dedicated. For dedicated, you create everything from scratch. You create your own Exadata infrastructure. You create your own VM cluster. You create your own autonomous container database. So you own the whole stack. With serverless, you don't have to worry about any of the stack, the underlying stack, but you basically focus on the database instance. And this is what we're going to do right now. So right-click, create new. I'm going to call it, let's say, the database names. I'm going to give it the same. The display name, I'm going to say webinar / okay. Serverless version, as I mentioned before, 19C, which is the current stable version of the Oracle database for the autonomous database. CPU count, I'm going to keep it like that. I'm going to click on always free, and a lot of things basically will be selected automatically for me. And I'm going to add a password here. This is for the admin user, okay? Okay, secure access from everywhere. If we have the always free version, we cannot enable walletless connectivity. But if you are not in the always free version, you can also opt in to use TLS and not use wallet-based authentication. So you have to download the wallet, etc., etc. We are going to do it because we are working with the always free version. So I'm going to click on create. Okay, database creation has started, and now we are waiting for the creation. If we go to the console here, okay, hope you can see my console right now. If you click here on autonomous database, right, you will see that it is provisioning, and we did it from Visual Studio Code, and that the one that it was in red has been terminated. Okay, and I have one available. All right. So we created the autonomous database. Let's wait until it gets created so we can actually connect to it from Visual Studio Code. Okay. Let's see. Database creation has started. Okay. Let's wait. You should get a confirmation here that says database connection has been created, and that's only 2 minutes. Okay, that's only 2 minutes, which is pretty fast, right? So in the meantime, while we wait, let me see. In the meantime, while we wait, let's code. Okay, so there we go. This is what I wanted to show you. Let's code. And the code is all available in my gist.github.com/Herman Viscuso. From there, you will see the 2 last entries there is all the code that we're going to use today. Okay. So if you want to just copy paste, you'll have the code there. All right. So let's go back to see if this is done. It's not done yet. Let's go back to Visual Studio Code. While we wait, let's go back to this section here. So you will see that I'm using this other extensions like Rust Analyzer, Code Runner, Code LDB. They are all option crates. They're all options, but if you want to copy that, you can go ahead and copy it. So I'm here in my Rust playground. Okay, so my Rust playground basically has two projects. Let's start with this one. And let's start with the cargo .toml. So this is ADB Rust O, okay? And this is what I'm adding as a dependency. I'm adding the dependency Oracle. So as you can see, my Rust program, when I want to connect to the Oracle database, basically needs one dependency, which is Oracle. And if we had the Oracle Instant Client Library correctly, configured, that's all we need, okay? So let's go and take a look at the code. Let's start with the most simple, basically information that we can get from the database, okay? And as you can see here, this is a sample that comes with, the Rust Oracle There you go. The database was created. Okay, so here you can see that the database was created. And the nice thing is that I'm working with Rust, and I'm working with my database. Everything I'm doing from Visual Studio Code, which is pretty good. Okay. So okay, so let's go back to this example in a sec, because I just want to connect to the database, and that's what I wanted to show you. All right. So once we created it, this is the one webinar, etc., etc., etc. What we're going to do is we're going to create a connection in the Database Explorer, okay? And here I've been having some issues with downloading the wallet. So this is apparently and supposedly you should be able to download the wallet here, provide the password for the wallet here, and basically get a connection right away. But this just sits there and it's not downloaded for me. So what I'm doing is I'm basically downloading the wallet manually, and I'm going to show you where you do that. This is the database we just created, okay? And I go here to database connections, and I go to the instance wallet, and I click on download instant wallet, and I create a password, you know, just wait a sec. There you go. So this is the password for the wallet, all right? This is not the password for the administrator of the database. It's a different thing. Here, I'm using the same password, but just this is a different thing, okay? And I click on download, and I place this zip file in my computer, okay? I unzip it, and I usually like to keep these wallets in the .oci folder, okay? So later, when I want to connect to the database and I downloaded the wallet, I go to the Visual Studio and I do not click here on download the credential, and I point the directory to that wallet. And if you take a look at this, for example, you will see here in OCI, I basically have wallets, okay? I point the wallet to the wallet, and I basically connect, okay? Then I say select folder, and that's it. And then I click OK, and I connect. I'm not going to connect because I did not download the right wallet right now. So basically, I'm already working with one where I did exactly this step, but I wanted to show you how to actually create a connection. Once you do OK, and you point to the wallet, you will get asked for the password, okay? And when you get asked for the password, you are connected. And what you will see is basically this, a connection to the database, okay? So once you see a connection to the database, you do this drop down here, and you will see tables, for example, and you will see relational tables, okay? So let's see if we can refresh, because I think I changed the name of one of the relational tables. Okay, there you go. So this is a connection. Now, if you have a connections, you can obviously query data, right? So for example, we could do show data here on a specific table, and we'll get the data, okay? Or you could do right click, and you can do generate the select SQL, and you will be able to basically got complete for you, but you'll be able to run any select SQL. Now be careful, if you click on this element here, this is basically for running code, and you get an error. You need to click on this other one, the one with a circle, okay, which is execute SQL, and that's true for anything that you want to run here from these elements. So we are up and running with this. Now let's go back to Rust. Okay, and the main. So as you can see, I'm using Oracle. Let me see if go bigger. I think this is too big. So we are using the Oracle binding, and we are using result, and we are using version. So what we do here is basically we request the client, and this is specifically for the Rust Oracle binding. We can basically access the client from the version object and basically show the Oracle client version, and that is fetched locally. So if we remove, for example, all of this, and we just run this, a connection is not even necessary. So that doesn't mean that it's working, because we're fetching the local client, okay? But that means that the instant client, at least means that the instant client is correctly configured, because we have been able to fetch the instant client version. Now we want to connect to the server, right? So in order to connect to the server, we are going to do a connection connect admin webinar and we are going to use one of the entries in the TNS profile with tsnames.aura, and this is inside the wallet. You choose one of these elements inside the wallet, okay? And you basically connect, and we are going to fetch the server version. So I'm going to run that now, for example, and as I showed you before, we start from here, and I do Intel, and I basically switch into Intel, all right? And I'm going to do cargo run, and I need to target specifically that, infrastructure, sorry, to target that CPU type. And as you can see, we got the server version. So this means that we connected to the server. So what is it that we did to actually get this connection? Provide a proper connection information, which is this is the password that I chose for this webinar, okay? And this is the admin password, not the wallet password, the profile admin, and one of the entries in the tsnames.aura, which is inside the wallet, okay? So, and then we ask for the connection version, all right? So let's do an example that it's a little bit more interesting, basically where we are actually querying data, all right? So let me do this. I'm going to use the same cargo.toml, so basically the same dependency. And I'm going to paste it here. I'm going to do save, okay? I'm going to explain in a while, but first I want to run it because I want you to see first what the output is, all right? Let me just save first, that'll be good. I think I have an issue here, one second. Oh, we are in the S, sorry. Sorry for that. Oh, the output was the same anyway, so don't worry. Now we're going to run. Okay, so as you can see, I'm basically getting like, different names for the different, categories of movies and the sales for each category, okay? So this is what we're doing, and this is coming straight from the database. So let's analyze what's going on here. We are using Oracle. The cargo.toml is exactly the same, okay? And we are using Oracle, and we are using the same connection information that I used before, but now I'm crafting my SQL here. Crafting my SQL, plain SQL, okay? And I'm creating a statement, and I am building, basically I need to provide the SQL and build a statement. So this translates into a tree of that SQL, okay? And then to that statement, I basically passing, creating a query. I'm basically starting a query from that statement, and I'm saying this 5. Basically, I'm saying, pass the parameter 5 to the query because we want to fill this top sales here, top sales parameter. So then I go into a for loop where I basically get the row column info, which is this name and sales that I want to fill in. I can get the column info, and then I just cycle through the rows and print the the name of the genre and the sales number, right? So this is basically a for that I'm going through with in those rows. And then I close the connection, and then I do an OK. Okay. So if you take a closer look at the other library, so let's take a look at the civil library. So this one is Rust Oracle. Let's take a look at the civil library, and let me just fill in the correct information here. Just one sec. Okay. This civil. I'm going to show you exactly the same. Okay. Exactly the same functionality. Let's take a look at the cargo, okay? But let me show you the difference in the cargo. When I use the civil library, okay, I'm going to save there. I need to basically use civil. I'm not using Oracle anymore. I use civil. I pass the version, and I basically have to say that I'm going to use the blocking version because civil has blocking and non-blocking. So you specifically need to signal out that you want to use one or the other. So I'm going to say blocking. And you will see that the code is actually very similar. Here we rely on an Oracle environment, and basically we say, okay, use Civil as Oracle. So things look even more similar because we start using Oracle, but it's actually Civil behind the curtains, okay? Connection information, I'm doing Oracle Connect, and I'm basically passing the same data, the username, the password, and the profile in the TS names Aura, which is in the wallet. I'm crafting my SQL, okay? I'm also passing an argument to the query, which is the number 5, and then I'm going through a while, cycle where I go row by row and print things. The Civil, to my knowledge, doesn't provide the way to get the column names. So I could not find how to get the column names here. You will see that that's not available. And also it wasn't necessary to close the connection, as you can see here. Maybe we should, but the code just works just fine. So let me just go and do that. Remember that we're still in Intel mode because this is yellow, right? So I'm going to go back to the other project. Okay. There. Right. And now I'm going to run it. Right, and this is connecting to the database. The database is an always free tier autonomous database running in the cloud, and also getting the same information from the same table. Look at what happens if we exit the Intel mode. Okay, let's just copy this. Oh, looks like it's working. See, apparently because I'm using the target, right? I think that because I'm using the target, then it's targeting, or maybe running Rosetta behind the curtains like automatically. So last time I checked, I was having issues, but anyway, if I do Intel, come back to Intel mode with Rosetta, and basically everything is set up. The good thing about the Rosetta environment is that it keeps the environment, basically keeps me in the same directory, etc., etc. Okay. So yeah, I thought that it was going to fail, but basically it worked. So if you have comments on that, let me know. All right, so let's do one last, because we are out of time already. Let's take a quick look at how to do inserts, okay? Because we have seen how to do queries. We are going to use, just give me one sec. We are going to use Rust Oracle, not Civil. Yes. Just let me find the right code here. I'm looking for the right code. Just give me a sec. I can't find it. Just one sec. There you go. I found it. So we are going to use Rust Oracle for that. Let me go here. Okay. Let me paste it here. Let me save. And this is the last piece of code that we will see. I'm going to be on Intel. I'm going to do okay, and I'm going to run it. I'm going to show you the output first, and then I'm going to show you the code. So we have inserts. We insert some rows in a table that we created called T. Then we updated those items, changed all the names to where the streets have no name, and then we deleted a few rows. Okay, and I wanted to show you how that works from Rust Oracle, and we are done, and we can do a couple of questions before the top of the hour. All right. So let me go back to the code here. All right. So let's go to the top, connection. Same way to connect, exactly the same way. Now we craft our SQL, but this time instead of being a select, we craft a drop table SQL, and we create a create table SQL. You might be familiar with this because there's a lot of SQL developers in this talk. And then instead of using query, we use execute. We can execute these statements about creating tables, dropping tables, inserting, etc. with con execute. So we just do that, okay? And here we deleted the table because I've been running this example like multiple times, so we need to delete the table. We deleted the table and we created a table. Now here we have an empty table, right? So we have some data and we have this as tuples, here defined in Rust. Now we want to create an insert statement, but how can we insert three things? So we create the insert into statement and we put the values as placeholders or parameters, okay? Now here we do create a statement. We build a statement, same like we did with the SQL select statement that I showed you before. We have to build it, okay? And once we build it, we can actually execute them by passing the parameters. So this will execute 3 times, which is the 3 items that we have here in this 4. This will execute 3 times and put the different parameters for each row there and execute the insert. You will see that I'm doing several commits here because I had some issues with parallel, basically the system expecting a commit and not doing too many things at the same time. And then I'm showing with display rows, I'm showing the rows. It's basically doing a for through the rows and showing the rows, okay? Then I do an update statement and I execute it directly, where I execute everything in the address, basically put where the streets have no name, and then I delete, a few. I delete from the table where the ID is equal to 3, and this is also an execute statement. And then that's it. Basically, there we have a bunch of commits and a close. Okay. So let me go back to the. We won't have time to see non-blocking code. The code is there. It's in my gist. Okay. So if you want to see how to do non-blocking, which is basically async, you can take a look at the code there. It's very simple. It's basically the same, but adding some async calls, right? So very quickly, if you're using these drivers, and this is an example, the Go driver, Go drawer, you will see that the architecture can get very deep. Like for example, you go from the Go language to the CGO libraries, that are the libraries that allows you to use C libraries. Then you go through ODPI-C, and then you go to the Oracle core interface. So that's a 4-level architecture, right? So stacking multiple wrappers might result in a lack of performance. So for example, here CGO takes 99% of CPU utilization. And if you are going to ship an application with this type of bindings, you also need the Oracle client library. So you have your customer to install the libraries, or they should come with the application and should be installed. So it's not super straightforward. What are the alternatives here? So you could use REST APIs, for example. We have something called ORDs that basically exposes APIs in the Oracle database, and you can use REST and do HTTP requests from Go, from Rust, from wherever you want. This is usually very fast. And you could also do something like this. For example, there are some use cases that are doing something like this. And this is from a very, this all comes from a very nice blog post by Goran Dumik, from a company called Cintio, where he was trying to measure the performance of the Go binding compared to doing something like this. Okay, so you might run Spring Boot with Java and just use JDBC to connect to the Oracle database. And this usually gave Goran better performance than the actual Go binding. But the Go binding is a very special case because it's a 4-level architecture, and it's using those CGO libraries that basically take 99% of the CPU when you do a database call, which is huge. Okay, all right. So I'm done for today. Let's hope we can do another session just like this to go deeper into the usage of the Rust with the autonomous database. There are more things that we can do, but I hope that I can get you up and running and ready to play, and do all your testing. Go ahead, grab, the always free tier on the Oracle database, and let's go to a quick round of questions if there's time, Violeta.
Okay, we are over the hour a bit, but I would propose to take some of the questions if our customers would like to stay with us for a couple of minutes or so. So let's quickly jump and just check the ones that we didn't touch, Herman, because we did answer some of them.
Okay.
So which one shall we take?
I've got a few that I responded to, Violet, if you want me to.
Choose an easy one.
Okay, so
because
there was a few people anonymous, so I'm not too sure this was always the same person, but there was one, they had plugins and links and any API libraries. So we're wondering, had you used any of them, Herman, setting this up? And if you did, could you share them?
Plugins and links in
the
API
libraries was the second one that they had. Anything that you added. So I think it's probably covered in your notes, but I just thought I'd raise it as a
I'm not sure if he's talking about the prerequisites, like what type of plugins I'm using in Visual Studio Code. So you can see them here.
I think that's what it was about. But again, anonymous, if it's not, feel free to post back.
Anyway, they can use Slack. You can Slack me in the Slack.
Okay. There was one by Abulesh. I hope I haven't butchered your name, dude. But he's using Power BI and Tableau. I know this is meat and potatoes to you being an HEP dude, but he wants to know, can it connect to HEP?
Yes.
Yes.
It's very similar. Like, for example, some people are using Tableau and some people are using Python. For example, there used to be, if you take a look at this, there used to be Python binding called CX Oracle, which now has been rebranded to Python Oracle DB. Okay, so it's basically the same thing. You need to expose the libraries of the instant client to the proper bindings and then connect. There should be a binding for Tableau. I think that there should be some kind of binding for Tableau, or you can do it from Python, for example, or you can do it from Rust if you want. But basically, those what you need to expose is you need to have the instant client, and you need to have it in the path for the shared libraries or dynamic libraries. Okay, so from Python, for example, you can connect to Tableau, and you will have to do a very similar exercise that I showed you today. All right.
Okay.
All right, another one.
Violetta, do you want me to keep going, or what do you want to do?
Yeah, please do. Please do.
Okay. There was one. There was a whole raft from anonymous, but again, I think it's the same person, but I'm not too sure. That's always the danger of logging in as anonymous. But anyway, there's a whole stuff on projects converting and stuff like that. But honestly, dude, I don't think we've got time. Anonymous, if you can join us on Slack and follow up with that, we can get someone to help you on that, because there's a lot going on some of them.
All right.
There was one by Otis. Is there a tendency to choose Apex over Rust or Rust over Apex?
Apex over what?
Over Rust.
Over Rust. Yeah. Well, Apex is a way for you to declare the application rather than coding. So the question should be, do you want to code or you want to define in high level what the application should be doing? It's like a different way of working. So you define the screens, you define what the application should be doing, and the code gets generated for you in Apex. Now, if you really want to code, you should go with Rust, because you can do some actual coding there. So it's a different mindset, a different way of working. Remember one thing. Remember that you folks can access the code in git.github.com/Herman Viscuso. It's available there, and all the code is there for you to play. Okay, I just wanted to reiterate that.
There's a lot more on deploying projects, but again, anonymous, that's probably way too big for trying to cover here in a couple of minutes, and we wouldn't do your question justice. I don't agree really, but how can you use, from Rafik, how can you use it for business application, like extension for Oracle application? I guess you're talking about Rust there.
How to use Rust for an Oracle application? I must say that I don't have experience, how to create like Rust extensions or plugins from specific Oracle applications. We will have to take a closer look at what is allowed in terms of Rust in those applications. And if you just call Rust code okay? From maybe you can create a plugin in Rust. You will have to make sure that you can access the instant client libraries. So that would be the prerequisite. You're running this Rust environment maybe inside a plugin, an Oracle application. If those libraries are not there, then you won't be able to connect using like Oracle, Rust Oracle or Civil. The libraries have to be available. And if the machine is constrained, I don't have access to it, etc., that might be a problem because I might not be able to install the client. But fortunately, the libraries come with the Oracle database installation. So if that machine that is running the Oracle application is running the database, the libraries are also there. You don't need the instant client. So you have a replacement for the instant client, which is the database itself and their directories. You will find the shared libraries there. Okay?
Cool.
Thank you.
Sorry, V, just on the anonymous one, just probably clarify, we've no way of knowing who you are. So if you want to ping us on chat right now, if you were asking those questions about transiting projects and moving projects and stuff, if you post it on chat, we can follow up with you on email, or you can join us on Slack and we'll follow up with any questions that you got there.
Yeah, one more thing. We are going to share the deck, and if you take a look at the short links on the top right on the slides, you will be able to access all the resources, like the 15-minute tutorial, the code, the blogs that I referred to, etc., etc. So please grab the deck because it's a perfect reference for you to get up and running. Okay.
Thank you, Herman.
Thank you.
And by the way, the deck will be shared with you on Slack in a couple of minutes today. And if you can't join Slack, feel free to email us at contact-d6-EMEA and we will share it with you there. Also, for today, I would only like to use 2 minutes of your time. It's really important to share some information, and then we will close the call. So the first and the most important thing that you need to be aware, and I see that so many of you were not familiar with the cloud coaching program that we usually run. So FYI, we host events on a weekly basis every Wednesday, same hour as today. There will be a session in the schedule, always a demo. We try to build these cloud coaching sessions based on your needs. So thank you all for joining this call. Herman, thanks a lot for giving us the pleasure to have you back at Cloud Coaching. We hope to see you soon again.
Thank you.
We hope you enjoyed the session, and of course, we hope to see you soon. Bye-bye, and enjoy the rest of the day. Bye-bye. Take care.
Thank you. Bye-bye.